What do you need to do first? Rewrite it. So rewrite it in a way that makes things a little more clear about ins and outs. 26 is 26. Instead of writing it as like secant cubed of 4x. Yeah, secant of 4x all cubed. And then it's a little more clear who's in and who's out. So the inner part is then what? Not the 4x. Secant of 4x. So this is nested chain rule. You have a chain rule inside of another chain rule. Big chain rule, the inner part is secant of 4x. And the outer part is, oh, you're right, the 26. I forgot that. 26 minus, yeah, sure. Who is that, Laura? Yeah. 26 minus n cubed. So that's in and out setting up. Easy stuff first. What's d out? Negative 3 n squared. Right? So the 26 goes poof because he's a constant term. Multiply exponent down in front, reduce the exponent by 1, and then remember that n is really secant of 4x. So this is secant of 4x all squared. We can put it back into that form, secant squared 4x. So that's d out. You guys have any comments or questions about identifying in and out and doing the derivative of the outer part? For the derivative of the inner part, he's got his own in and outside part. What's the inside part for secant of 4x? 4x. What's the derivative of the 4x? 4. And then what's the derivative of the secant? Secant and tangent. Now we got to figure out what goes inside the secant and the tangent. What goes inside of them? 4x. So it's secant of 4x and tangent of 4x. So you put all these things together by multiplying your d in and your d out, and that's f prime of x. So what is on the outside of this whole mess? Like, what's the number outside of everybody? Negative 12, because negative 3 times 4. Then how many secants of 4x do we have? 3. We have a secant squared over here, and another secant of 4x here. So altogether we have a secant cubed of 4x, and then we have a tangent of 4x. So all that stuff's being multiplied together. You guys have any comments or follow-up with getting your derivative? Once you have that, what do we plug in? 0. Because all we want is what's the derivative at this point, right? Is that the whole goal here? So all we wanted to do is get the derivative at that point. All the heavy lifting is here, getting the derivative. Once you got that, just plug in 0. Now, we have secant of 0 and tangent of 0. Unit circle time. What's secant of 0? 1 over 1, right? Because cosine of 0 is 1, and secant's the reciprocal of that. So this is negative 12. Secant of 0 is 1. It's getting cubed. And what's tangent of 0? 0, because tangent is sine over cosine. Sine of 0 is 0 over cosine of 0 is 1. That's 0 over 1. So tangent of 0 is 0. So altogether, this derivative is a 0. So you got to kind of go back and be able to evaluate a trig function at angle 0. Any questions to follow up on 73, Prince?
So, we wrote f prime of 0. Above that is just f prime of x.
Mm-hmm.
Yeah, the whole thing. So, like, on my paper, I just wrote the first line, and, like, I just wrote f prime of 0.
Okay, that's fine. Any other questions? Yes. Here, who's inside? X squared. So this one's nice. It's just the inside getting squared, not the whole trig function. So we have in. What's out? Cosine of n. And then instead of like doing d in, d out, let's just put it together right now. What's the derivative of the inside? 2x times, what's the derivative of cosine? Negative side, and inside of that you have an x squared. You can clean this up a little bit and make it negative 2x sine of x squared. And that's your first derivative. But we want the second derivative. So we keep going. Sorry, that's still f prime. Now to differentiate this guy, what do we now need to do? Product rule. Why do we need to do product rule? We got 2x things multiplying each other. We have a negative 2x times a sine function of x. So this is now product rule with a first function and a second function both involving x, and they're multiplying. So that's what we got to use, product rule. So to get our second derivative, product rule says do the derivative of the first guy. What's the derivative of our first guy? Negative 2. And the derivative of the first multiplies what? The original second, sine of x squared. Then you add to that the original first guy. What's our original first guy? Negative 2x. And that multiplies the derivative of the second. For derivative of the second, what rule do we now have to use again? That's another chain rule. So this is a product rule problem with a chain rule built into it when we do the second derivative. So when we do the derivative of sine of x squared, what's the derivative of this guy's insides? 2x. What's the derivative of sine? Cosine. And what's inside of cosine? X squared. So that is your product rule setup, where the derivative of the second part is his own kind of little chain rule problem. Very similar to what you did to get the first derivative. Now that you have all that, you can clean this up a little bit. That's his negative 2 sine of x squared on the front. And then on the second half of this, we have negative 2x times positive 2x is negative 4x squared cosine of x squared. And now what are we plugging in? 0. So we got to just plug in 0. What's sine of 0? 0. And 4 times 0 is, so do we even care what cosine of 0 is? No, because 4 times 0 is going to kill it. And so this is a 0. Ta-da! Moderately tedious. It's not the worst thing in the world. There was much worse stuff on the previous one. Any follow-up on this one? Yes, Akshay. Yeah. So d second is a chain rule. So when you take the derivative of this guy, he's got his own inner part, x squared, and outer part, cosine of in. I didn't write it down over in the margin. I'm kind of doing that in my head, keeping the ins and outs in my head. So this 2x is dn for this guy. And then cosine of x squared is d out for that guy. So as you're doing your product rule, and you get to doing the second derivative, doing the derivative of this second piece, you see, hopefully, oh, that's got an inner part and an outer part, so that means its own little chain rule. You need to go over into the margin and do the second over here with, like, write out the chain rule over on the side and then bring it back in. That's totally fine. Any other comments on 99? 101 and 102. Chris, could you kill the light, the back light switch for a second, please? All right, so for 101, one of these is F and one of these is F prime. Now, when you have them both on the same graph, I think the best way to do it is just guess who's who and then check and see if it works out. So let's pick the parabola. What do you want the parabola to be? F prime. All right, so if S is F prime, then this guy's F, and then we kind of reason it through. So remember, F prime is the slope of F. So look at F. Way out here on the left, what's its slope? It's positive. Is F prime currently positive? Yeah, because it's above the x-axis. Then you get to right here, and what's the slope of F right there? Which means F prime should be at a height of, and look, it is. And then where else do we have a slope of 0 on F? Over here, like almost 2. And you look and you see, hey, F prime is at a height of 0 again. That's a good sign. What's F doing between these two key points? Going down, so F prime should be negative. Is your parabola negative here? Yeah, because it's below the x-axis. So that works. If you guessed the other way, maybe you said, I'm going to make our parabola f and this guy f prime. That wouldn't work because, well, first of all, you guys know about parabolas. What's the derivative of a parabola? It's a line. Does that thing look like a line to you? Nope. So that's a way you could do it, is you say, well, parabolas have a derivative of lines. That thing is clearly not a line, so parabola can't be f. Now this one over here I thought was a little tougher in terms of figuring out who's f and who's f prime. But when in doubt, just make a guess and then try to reason it through based on your guess. And if you reasoned out wrong, and your guess was wrong, you just swap. So what do you want to make your guess? Do you want your f to be the thing or the thing, the first thing? All right, let's say this guy's f and then this guy's f prime. Hopefully you understood that these two things go together and you weren't pairing like this guy with this thing. So looking at your f, what's the slope way out here on the left? Negative. So f prime should be negative. That means below the x-axis. Now, as you get closer to this ending point, what happens with the slope? Do you get more or less steep? More steep. So like if you're going down a hill, like you can be going down a hill, which, as you're going down the hill, which hill is steeper? The second one, right? This is steeper than this guy, so the slope is more negative, right? So you don't say, well, I mean, the slope is like closer to being positive, so it's steeper. No. Just like how fast would you be falling? You're falling faster on this guy. As you fall down this hill, as you get near the end, it gets a little steeper, so you're going to be falling at a faster rate there. And so f prime should get more negative, which it does. So that checks out. And then over here, what's your slope on this piece? Positive, and therefore f prime should be above the x-axis, positive. And that, so our initial guess of like who's who checks out. Any follow-up comments on 101 and 102? That was there mostly as a, hey, remember doing this stuff when I did here's a graph, sketch the f prime? It's similar, except they're giving you both graphs, so you got to figure out which one's which. 111. What does the F stand for? Is that frequency? So big F is frequency, V is velocity. So frequency is like the pitch of the sound. So you have a fire truck coming down the road at you, please move, and he's got his wee-oo thing going, siren, that's what they're called. And like the pitch of the siren is its frequency, how high and obnoxious the sound is. And you guys have been there, like the cop goes by, and as it's coming towards you, it has one sound, and then it gets past you, and then suddenly the pitch drops an octave or so. So the plus V and the minus V has to do with that. If the velocity is plus V, is the truck moving towards you or away from you? Nope, away from you. So if velocity is positive, it's getting farther away from you. So the distance between you and the truck is increasing. If it's coming towards you, then the velocity is negative. So when the truck is approaching you, we're going to be using the 331 minus V equation, 1. And when the truck is moving away from you, then we're using the 331 plus V equation. Chris, could you turn the light back on, please? So what you need to do in 111 is figure out f prime and then plug in 30 to your f prime equation to see what's the rate of change of the frequency, how is the frequency changing as the truck comes towards you, and then as the truck moves away from you at that speed. So for this one, you're using f equals 132,400 over 331 minus V. And over here, you're using f equals 132,400 over 331 plus V. And all you have to do is, once you say, okay, I'm using this equation here and this equation here, what rule do we have to use to differentiate? quotient rule. So you use your quotient rule, get f prime, and then plug 30 directly in for v in your results. Do we need to go through the getting of f prime with these equations? I think quotient rule is pretty straightforward on these things. I think the hang up is maybe getting started and knowing what to do. So can somebody tell us what is f prime on the, or when it's 331 minus v? Oh, is that all it is? Well, that's wonderful. I'm going to go out on a limb here. Is this one the same thing but with a plus v? Oh, and it's negative up top? Okay. So let's just do your quotient rule. Low D high minus high D low all over low low. Low D high minus high D low on top. Cleans up really nice. And then you got your denominator squared. Once you've got these, just plug in 30. So when you do that, 331 minus 30 is 301. What's 301 squared? A little more than 900,000? Or 90,000? So 90,000 what? Could somebody help tell me, please? 601? So this is the same thing. No, it's not. This is going to be bigger. This is 361 squared. What's 361 squared? So 100, what? 130,000. 130321. And you can just divide those out for yourselves and see what that is. And physics people, what would the units for that be? Hertz. Hertz? So,
meters per second.
no, the velocity is meters per second. That's how fast the truck is moving. The F is the frequency of the sound. Did they use meters per second? The problem, F is measured in meters per second.
It's hertz.
I find that hard to believe that it would be meters per second. If it's on the key could very well be wrong. I'm trusting the guys in AP Physics. We'll call this hertz. What is this? It's HTZ. So that's all I had to do. And probably they're right that it's hertz. Probably my key is wrong that it was meters per second. All right, last thing here that we wanted to look at, or at least that we had space to put up here, points with a tangent line to that thing is horizontal. How do we go about finding that? Yeah, find f prime of x, and then set that equal to 0. Because if the tangent line is horizontal, you know your slope is 0. So, like, on the relative problem on the quiz, I think this is like 5 points. You get 1 point for getting the derivative correctly. Now, if you mess that up, not all hope is lost. You could get the wrong derivative, but then use it the correct way. I'll give you points for doing things the correct way, even if you get the wrong derivative to work with. So you get a point for your derivative. You would then get a point for setting up your equation f prime of x equals 0. So then you'd have fill in the blank equals 0. That would be a point just for setting that up. And then you would get a point for solving and getting your x solutions. And then you would get 1 or 2 points for your final answer. So you could get the in-between points. Your answer would be wrong if you messed up your derivative, probably. But if you did all the intermediate steps right, you'd still get like a 2 or 3 out of 5. So you can mess up your derivative and still get like half credit or more based on the in-between work if you say, all right, I don't know what my derivative is, but at least I know I need to do this, and I can solve that equation. Now, we should probably be able to get the derivative. In order to get the derivative, what rule could be used? Probably quotient rule. This doesn't look like it's going to be fun quotient rule, is it? No. Yeah. Oh, well. Low. What is it? Root 2x minus 1. D high is 1. That's not so bad so far. Come on, what's the problem, guys? Minus high x. D low. This fucks us up. Sorry, so I'm going to write 2x minus 1 down here. 1 half. So what's the derivative of this thing? That's d low. So 1 half times 2x minus 1 to the negative 1 half times 2 because of the derivative of the inside. So these cancel and leave you with. So this is chain rule, right? You have an inner part and something happening to it. So the derivative of this inner part is 2. And then the derivative of the outer part is 1 half times the inside to the negative 1 half. So it's easy to miss that 2 and forget to include it. So the 1 half and the 2 then cancel and leaves you with just the 2x minus 1 to the negative 1 half. So that's low d high is nice, minus high is just x, and that's d low. Over low low, what's low low? Yeah, it's 2x minus 1. Because you square the square root, and you're just left with 2x minus 1. So let's clean this up. Let's put that back to the tire floor. It's fine. All right. So if we wanted to clean this thing up, we'd have to try to multiply by fancy 1. What's our fancy 1 going to be? 2x minus 1 raised to the positive 1 half. You want to kill the negative exponent, so use the same exponent for positive. So you multiply by fancy 1, you're multiplying by 2x minus 1 to the positive 1 half. When you do that, what's root 2x minus 1 times 2x minus 1 to the 1 half? That's a 2x minus 1. And what happens with these 2x minus 1s? Cancel out because they have opposite exponents, and you're left with just the minus x, right? So that's your numerator. 2x minus 1 for the first half of the numerator and just minus x in the second half of the numerator. Downstairs, you have 2x minus 1 raised to the, well, how many of these things do you have? 3 halves, because this is a full 2x minus 1, is one of them. And then you have another 2x minus 1 to the 1 half. So altogether, you have 2x minus 1 to the 3 halves. So that's f prime of x. Clean up your numerator, you just got x minus 1 up there. So that cleans up remarkably nicely. So when you have some factor with a negative exponent in your numerator that you want to kill, multiply by that same factor but to the positive exponent. And that'll kind of clean out the negative exponent. It's gone. And hey, 1 half and 1 half make a full 1, so that's just 2x minus 1. Now we said you set the derivative equal to the slope, and the slope is 0 because it's a horizontal line. So you have x minus 1 over 2x minus 1 to the 3 halves equals 0. I don't know why I put that. And how do you solve this equation? Bring the denominator over, and it gets zeroed out. Hooray, 0. You just got x minus 1 equals 0, so x equals 1. What do you do with that? Put it back in to get your y so you can find the point. When you plug 1 back in, you got 1 on top. And on the bottom, what's 2 times 1 minus 1? 1, so the square root of 1 is 1, so that's 1. So the point is 1 comma 1. So on your test, quiz, whatever we call it, where do you get points? You get points for your derivative. You got to show work to back it up. You're doing that in your head. Wow. So you get points for your derivative. 1 or 2 points. Then you get a point for just setting up this equation. Derivative equals slope. Hey, slope is 0. Boom. That's a point. You get a point for them solving this. So you solve for x. That's a point. And then you get points for your final answer. Actually, you get a point for your y. And you get another point for your final answer. So that's 5 points. You can mess up your derivative and therefore mess up your solution at the end and get the middle 3 points if you know what to do with the derivative in between. Questions? Zelda? Then lucky you. You only lose that point. It happens. On the AP exam, this is an AP class, but on the AP exam, half the test is multiple choice. If you do wrong stuff on the multiple choice and then select the right answer because you just got lucky, you get the credit for it. Yeah. They don't see your work for the multiple choice, and they don't care. Oh, you put D, the answer was supposed to be D. I don't care that this person just randomly guessed for D. I don't know. He gets the credit for that problem. So you show that you know what you're doing. If you luck into the right answer, you get that point. You got the right answer. Lucky you. You're probably going to make a mistake somewhere else where you'll lose a point. I don't know. But you get that point for having the right answer. So that's like how I'm looking to grade things. When are we out of here? 43. Do you have any further comments or questions? Thanks. All right, the dice. 5 and 4 and 6. So you guys, because there is no row 6 anymore. Yeah. Thank you. I didn't ask anybody. So all the rest of you, rows 1, 2, and 3. I'm assuming it's a yes. You don't need to tell me if it wasn't. But if your conscience is going to bother you about that, you can tell me and I'll put a no if you want. Thank you. I have 2 no's for you. One from, I have you telling me no twice. Is for 2.2e. And that was a row, it was a time I collected your row. So maybe you never got around to handing it in. And it was like, oh, that's right.
I know exactly where it is right now.
Okay.
So I'm gonna bring that in tomorrow.
Okay. All right, do you want to do yet another find the equation of the tangent line to this function problem? Or do you want to do graphical analysis? The first thing? All right. Here's your function. For example 13, f of x equals 2 sine of x plus cosine of 2x. And we want the equation of the tangent line to f of x at, let's give you a point, x equals pi. So go ahead and work on finding a derivative right now. I'll give you guys a head start while I find the graphical analysis problems that I want us to do anyway on here. There we go. There they are. Like that? 1. So I'll give you one graph like this. I'll say Q equals F divided by G, something like that. Tell me F prime or Q prime, and then find Q prime at such and such a point or something like that. So we'll do an example like that here too today. And then tomorrow is going to be come in, grab a whiteboard, and we're doing a review the whole class after that. finding f prime. Move the camera. Say again? Formulas?
Recording.
Yes, I am recording. Thank you. Sorry, my hearing is not great, and the masks have not helped things for me. I have my mom's hearing to look forward to in my future, unless I die first. Hopefully, hearing aids are better in another 30 years. Anyway, I'm glad that got recorded. What's the derivative of 2 sine x? Oh, before you plug, just 2 sine x. Forget pi for the moment. So what's the derivative of sine x? Cosine x. The derivative of 2 sine x is 2 cosine x. That's just straight, use your derivative for sine, not even chain rule, nothing special. No product rule, just direct differentiate. Cosine of 2x, now we put the 2 inside. Does that change how we do things? Yeah. Now what rule do you use? Now that's chain. And so what's this guy's derivative? Negative. Negative 2, and then sine of 2x. So why negative 2 on the outside? Yeah, because derivative of 2x is 2. And then derivative of cosine is negative sine of the 2x. Any questions with f prime? Just getting that. What do we do with that now? Plug in pi. And that'll give us the slope. So we say the slope m equals the derivative at pi. So we got to know what's cosine of pi, and we got to know what's sine of 2 pi. So, unit circle time. What's cosine of pi? It's negative 1. So pi is halfway around your unit circle. When you're on the x-axis of your unit circle, cosine is 1 or negative 1. That's halfway around. You're on the left side, so cosine is negative 1. Sine of 2 pi, this is all the way around the unit circle once. You're back where you started, so this is the same as sine of 0. So what's sine of 2 pi? 0, because sine of 0 is 0. Same thing. And so our slope is negative 2. We got our slope. Now, what else do we need before we go and write the equation of our line? We need our y. And how do we find out y? Plug pi into the function. So y equals f of pi, just like m equals f prime of pi. So you plug pi into your original function. And what's sine of pi? 0. And what's cosine of 2 pi? All the way around, same as cosine of 0, that's 1. So your y-coordinate is 1, so your point is pi comma 1. So now you can put these things together and write your equation. Y, I like point slope form, so y minus 1 equals your slope times x minus the x-coordinate. Ta-da! Prince.
So on the exam, would you have to write down that? Do you have to write it like y equals f pi?
No, you don't need to write this. That's a teaching aid. Here, you want to get y by itself? I don't. I see no need to do that. All right, last thing for today. Reading a graph, doing some calculus with it, extracting some information. So, say you've got this function h of x. You look at the graph and say, I don't see h of x. Chris, would you please kill the lights, please? And so what you have are f and g, and we're telling you h is f of g of x. So if we want h prime, what rule do we have to use here? Nope. Chain. Product rule would be f of x times g of x. This is f of g of x. So this is a composition where you've taken g and put it inside of your f. So if you see this, product rule. If you see this, f, and then g is inside of it, that's chain rule. So to do your chain rule, what's the derivative of the inside part? G prime of x. What's the derivative of the outside part? f prime, and what's inside your f prime? G of x. And then we want to do h prime of 1. So that means you plug in 1 for your x's, obviously. And this can get a little messy. So we need to start off by finding g prime of 1 and g of 1. So go to your g function. Here's 1, there's g. So what's the height of g right there at 1? 4. So that's g of 1. So you're going to have f prime of 4, because g of 1 is actually 4. What's g prime of 1? Well, what's the slope of this guy? So, going up or down? Down. Down how much and over how much? Down 1 and over 2, so that slope is negative 1/2. And then you got to go to your f at 1, f at 4. And so here's 4, here's f, and we want f prime of 4, so we want the slope of the f line here. What's the slope of f? Negative 1. So that ends up being then positive 1/2. So chain rule in this situation can be a little confusing because, first of all, it's easy to look at that and say, oh, that's a product rule problem, and confuse g being inside of f with multiplication. It's not multiplication. So you got to write, oh, that's chain rule, and then this thing right here, g of 1 you do, and then that gives you a number, and then you got to do f prime of that thing. We'll do more of this practice tomorrow, I think, as part of a review. And then tonight is kind of a review of like everything you've done throughout this section on chain rule. So tonight is kind of going back through all the text that we've seen through this section. Where did the 4 go? So f prime of 4, you go to 4 on the f curve and you find the slope, and that's how we get a negative 1. Yeah. So you have homework tonight. Last homework, no homework tomorrow night or the following night. So last homework for like the next 3 nights. How do you guys do yesterday? No. I talked to Gary, he says that he was fishing. He gave me some numbers. Like, sounds like he's pretty good. But you get him around? Did they hit him? No? Oh, errors. Is it a home game? Oh, that, no. I played soccer on that field. I know it sucks. Have you guys had injury problems with that field yet? Oh, that's not. Yeah. I'm always afraid if somebody's going to be backpedaling to catch a fly ball and like break an ankle or a knee or something.
The sun.
Well, the sun. I kind of feel like that's his own fault. Yeah.